Sir, wait, sir. Sir, wait, sir. We will start the session. Yes.
Okay.
A graceful morning to one and all. Each day is a new day, a new opportunity to work towards making your life the way you want it. With this spirit, let us start this day. Let us have the first session. I feel honored to welcome Ms. R. Tunnel, Assistant Professor, Department of Physics, to felicitate Dr. R. Thangappan, Assistant Professor, Periyar University. Welcome you, ma'am.
Pleasant morning to everyone. I am highly honored and a pleasure to introduce the chief guest of today's webinar, Dr. R. Thangappan. He has completed his BSc Physics at Mahendra Arts and Science College, affiliated to Periyar University, and completed his MSc Physics at Pachapas College, affiliated to University of Madras, Chennai. He obtained his PhD Physics at Center of Nanoscience and Technology, Anna University, Chennai. He was a visiting professor in Department of Physics, Dharmamal Government Polytechnic College for Women, Chennai during the period July 2008 to 2009. And also he handled class for MTech and MSc students and Center for Nanoscience and Technology, Anna University, Chennai. He joined as an assistant professor in Department of Physics, Bharat University, Selayur, Chennai during the period September 2016 to February 2017. At present, he is working as an assistant professor in Department of Energy Science and Technology, Periyar University, Salem. He also has received award as a DST Pure Fellowship in Center of Nanoscience and Technology, Anna University, Chennai. He has published 17 research articles in internationally reputed journal with high impact. Also, he is a reviewer for 13 journals. He has organized international and national level 4 workshop and 3 conference in the year of 2017 to 2022. He also guided MTech, MPhil and MSc students for their research project, and he has efficiently trained to operate the 11 instruments such as atomic force microscope, particle size analyzer, SEM, powder XRD, etc. At present, he made significant contribution out of the project and synthesis and analysis of nanoparticles development, electrode material for energy storage applications. We are blessed to have such a great person who comes to the level is eager to contribute his multidimensional talent for the development of us. Now I request our chief guest, Dr. Thangappan, to take over the session. Once again, and welcome one and all. Thank you.
Thank you, madam. Thank you for your brief introduction about me. Can I? The audience, please. My PPT is visible.
Yes, sir. PPT is visible and the voice also visible, audible, sir.
The full screen also is visible, no?
Yes, sir. The screen also visible, sir.
Okay. Okay. Thank you. Okay. Good morning to one and all present here. Thank you for the giving the opportunity, and thank you for the realizer for giving me an chance to present my work and also discuss about the 2D materials. And today's topic is the influence of nano architecture composites for high performance and storage devices. Myself, Thangappan, Assistant Professor, Department of Energy Science and Technology, Periyar University. Okay, and although we have a demand in the energy demand all over the world, nowadays all the world towards moving to the renewable sector because of we are losing the fossil fuels, so the world is moving towards the renewable energy sector. Here shows the figure shows the percentage of usage of the utilization of energy, petroleum, coal, natural gas, and all, and also the Indian scenario of usage of power in the year 2014 to 14 to 2022. And here on the fourth figure shows the usage of cars. Nowadays, all the people are using cars, and the people are using uh, that is for fuels for the running the cars, and demanding the energy. Nowadays, the government also is facing that in usage of the electrical cars. Nowadays, all the uh, cars are coming out with an electrical vehicle. And here's the Indian scenario. This energy consumption sector 2020, and there's oil 34%, natural gas 24%, coal 23%. And total generation of total energy generation in India is around 22, that is 1,491 billion units. And it is a two generation. This usage is mostly the main countries, developing countries, so that we are concentrating on the fossil fuels only because of we are developing. Only with the renewable sector is growing. Already, that is India has in target of achieving the renewable sector to 2022. That is the 20 gigawatts of utilizing both the solar, wind, and other renewable sources. These are some uh, that is a scenario of Indian scenario of the renewable sector. Coming to the topic, that is energy storage system. It's all about the energy storage system is one of the system which in emerging system with technologies they can help to store the energy and also reduce the power consumption. The storage system is very useful. It is for transportation, emission, everything. It is very useful. So that energy storage system is very highly appreciated. Types of energy storage systems. There are many types of storage systems: chemical, electrical, electrochemical, mechanical, and thermal energy storage systems are there. In that, electrical systems, capacitors, supercapacitors all are there, and then electrochemical capacitors, batteries, fuel cells, and all other things that comes under the uh, mechanical or thermal like that. I will focus on the supercapacitor because my work concentration, I am working in the supercapacitors for the energy storage application, so that I will focus on the supercapacitors. Supercapacitors are the ultra supercapacitor, or called as ultra supercapacitors. It is an electrochemical capacitor that has an unusually high energy density when it compared to a common capacitor. Their particular interest in automotive application of hybrid vehicles as an supplementary storage for the battery electrical vehicles. This is the definition for supercapacitor, and the comparison of energy storage devices. We compare the Rangoon plot with energy density and power density, energy density x-axis and power density y-axis. We can see that the electrochemical capacitors comes under utilization of both the power density and energy density is very low and power density is very high compared to other things. So that only it is used in many applications, and also high power density and short term of acceleration and recovery of energy for the electronic devices. And it is so that only the power density is very high, so that only it is used for many kind of triggering the applications. That is the electronic applications can be used electronic capacitors, and also the rapid charging discharging process also been done in the supercapacitors. Some of the electrochemical capacitors utility scale in the applications, and the many companies they are nowadays they are focusing on the manufacturing the supercapacitors. Most of those are from the foreign countries only. In India, there is no company manufacturing this kind of work with this kind of devices. That is, many companies, best cap, supercapacitor, power store, or Diana cap, and the ultra capacitor capacity cap, power boost cap, like that. Many companies are developing the supercapacitor devices for different applications, and here you can show the capacitance also is there already different ranges. For a bar like that one also it can be stored at 12 volt 12 volt range also it can be manufactured and used for many kind of applications like storage purposes also or battery backups also. Different kind of application the storage purpose is used. That is basics. We will go some slides. We can concentrate on some basics of capacitor. Then we'll go for the materials. That is an here the mechanism is nothing but that two electrodes with differentiated by a potential range, and then the C is equal to Q by V. That is an Q is the charge and V is the volt. E stored is energy stored is equal to half CV square. That is and V is equal to substitute the value. Can find out the Q by C. Already you can know that half VQ. That is an energy stored value. The figure shows that kind of supercapacitor is there for in the commercial applications. And then classification of electrochemical supercapacitors, that is electrical EDLC, the equation is already we know that. That is an carbon-based materials are the large surface area, activated carbon and the allotropy of carbons are used for EDLC purposes. We have an advantage is we have a high power density, excellent charge discharge cycling stability, and a limitation is low energy density owing to relatively low specific capacitance. That is why it is combined with an metal oxide or metal sulfate or metal based material, so that it is used for synergetic application. Pseudocapacitors, transition metal oxide, hydroxide, sulfides, and nitrides are conducting polymers. It is a pseudocapacitance behavior will be occurred. That is, the Faraday reactions will be occurred in the cell. That is, oxidation reduction process will be done in the cell, and then it has an advantage is the high specific capacitance because of the charges are stored in the electrode surface, fast and reversible Faraday reactions, and then it has a low electrical conductivity and poor head capability. So that only the pseudocapacitance are not alone used for the supercapacitors. Fundamentals, that is when it is charge is it is not accumulated near to the electrodes, it will have a potential not charge. Potential charge means that the charges be aligned near to that of electrodes. That is the idea of the supercapacitor. Normally capacitance is equal to rho, that is V sigma or V sigma not V d into A. Sigma is that is an electrolyte and electric constant, and the permittivity of vacuum sigma naught. And A is the surface area of the electrode, X of the electrolyte ions, D is the effective thickness of EDLC, that is D by length. And that is, and also here you have the three kind of layers charges will be accumulated near the electrode. That is Helmholtz model and Gauss-Chapman model and the Stern model. The inner Helmholtz plane refers to a distance of the closest approach, specifically observed ions, that is generally anions, that is having the inner Helmholtz plane. Outer Helmholtz plane is refers to the non-specifically observed ions. This ions will be not observed. That is in the outer Helmholtz region. The figure shows the ions how it is observed. The distance between that electrode and the ions, it is noted that they have diffuse layer, Stern layer in between that, and then ions how they are attracted towards that the electrode. And then the porosity of the electrodes makes a major difference for potential storage sites. That is in the electrode. How they mean C1, C2, that is they been calculated. That is CH represents capacitance of Stern type compact double layer. C difference is the capacitance of diffuse region. That is in a porous electrode with high specific surface area. That will be very useful for the electrolyte absorption. Small separation between the electrodes, resulting that the great capacitance value, that is per unit volume. That is the concept of the porous structure of the electrodes. Fundamentals of LCD is overall capacitance will be 1 by C1 plus 1 by C2. That is symmetric electrodes means both the electrodes are same material, which will act upon that N-type and P-type material like that. That is C1 is equal to C2. The total capacitance will have either half of the either electrode capacitance. That is a symmetric symmetric capacitors. Asymmetric capacitors, one electrode will be working electrode, another one will be an carbon based material will have an another electrode. That is an ET is and CT is mainly dominated by the electrode with a smaller capacitance value. It is the concept of the calculation. And then the resistance, major drawback in the electrodes will have, and resistance is responsible for the self discharge of a single electrode. Ultimate aim is to the supercapacitor, that is energy should be stored longer time. For that reason, only the energy density will be increased. That will be depends upon many parameters. Uh, one of these is resistance. Resistance will have an between that electrodes and the electrolyte ions will be interacting between them. That the resistance will be responsible for the discharging that ions. That is one of the fundamental ratio. And estimation means the self discharge rates are related to the potential losses of a charged electrode over the period of storage time. That is an self discharge rate. And cycle type is an charging and discharging cycle will be done for a certain number of cycles. To have the initial and final capacitance, we can calculate the capacitance value, mean the charge tension value of the electrodes, working electrodes. That is effects of the electrochemical supercapacitor performance, that is electrolytes and electrolytes. That is capacitance means the ion size matching between the pore size and ion size. And then electrolytes means ionic conductivity, ion mobility, viscosity, like that. And thermal stability means boiling point, freezing point, and then salt solubility. Energy density, we should go, these affects means electrochemical stability and concentration of the electrolyte. And then cycle life, stability, ion electrode material interaction. And then power density, the potential window, ionic conductivity, ion electrode material interaction. That is all the effects of the electrochemical capacity performance. Advantages to the batteries, it is very high rates of charge discharge, little degradation over hundreds of the thousands, hundreds of thousands of cycles, good reversibility, and also low toxicity of materials used, high cycle efficiency, that is 95% or more. It is layman example how it will be. It is a 100-meter race, and then slow race will be how it will be there. That is a battery slow race and a fast cycling. Have an supercapacitor. That is layman example. Application of supercapacitors depends upon the discharge time. It will be used in many kind of applications like that. That a small discharging time will have in many kind of applications, power, memory backup, and like that. Capacitance values means you can use to energy storage systems and power, like that. High energy storage one means it is used in cars, automotive cars, and railways, etc. That can be used for many kind of applications. Like then supercapacitor is fabricated in bars and like an tubes, everything used for different kind of application. Nowadays the cars also instant power, the supercapacitors are used, and the supercapacitor used in many kind of applications now in all the many kind of automotive, and then uh, robots, and then electronic devices, like that. Many kind of application depends upon the necessity the supercapacitor use. Coming to the materials, these are the basics of the supercapacitors. Next to this materials of the for supercapacitors. Many materials are used in the supercapacitors: metal oxides and metal chalcogenides, or perovskite materials. Many kind of materials are used, but two-dimensional materials plays a major role in supercapacitor because of already we know that two-dimensional materials have large surface area, and all the storage sites will be increased in the because of the large surface area, and then interaction between the material will have many access points for the storage sites, will have a major advantage in the two-dimensional material. So that only two-dimensional materials are used in storage applications, many batteries or supercapacitors or energy conversion devices, like that. Nowadays many kind of applications comes out with the two-dimensional materials only. Quantum size effect is a major one for the two-dimensional materials. Is how the discrete values will be having in the quantum well, and the quantum wire, and quantum dot, and Bell supercapacitor. And then the layers, easy to band structure tuning. That is a major one in the two-dimensional materials. Uh, it is a major one, because we can structure of the easy to structure can be, we can easily tune. That is a major one. And sharp interface and interest physics can be done in this two-dimensional materials. Example, in the bulk material, you can see that the dangling bonds will be acted on the surface will be very less, so that the interaction between the outside foreign materials towards the bulk material is, and also the linking very less, so that the application point of view, it is very less efficiency will be achieved in this bulk material for any storage applications. In two-dimensional material, it have on thickness also very uniform, and dangling bonds also very free, and then the ions interacting towards the surface is very large, and also the activation energy also very small for interacting the molecules, and the ions, positive and negative ions, like that. So that only it is used in many kind of applications in electronic devices, like that. Two-dimensional materials is having many kind of high surface area interaction, thin and low weight, fast diffusion, defect engineering, and remarkable electron conductivity, high thermal conductivity, impressible of glass, and then high mechanical properties, yet flexible. So like that, many kind of properties in two-dimensional materials is there. For that reason only, the two-dimensional materials are being used in many kind of applications. Next, come to the two-dimensional material is graphene. Graphene is one of the revolution created in the two-dimensional materials. After inventing the graphene only, two-dimensional materials will be focused. Many researchers are focused on the two-dimensional materials. In 2004 only, that is, the graphene is been discovered by the professor Andre Jim and his student. That is, both of them got the Nobel Prize in 2010 for discovering the graphene material, and in the University of Manchester. Graphene material is an allotropy of carbon only, and it is one sheet like forms it have a graphene. If it is ball like mean buckyballs, it is the rolled one tubes means the carbon nanotubes. Three-dimensionally we can see means the graphite structure is like the structure of the graphite. Graphene is an one atomic thick planar sheet of carbon atoms that are densely packed in the honeycomb crystal structure lattice. And graphite itself consists of many graphene sheets stacked together with an interplanar spacing of 0.335 nanometer. That is a very small distance, and also the carbon-carbon bond length graphene is approximately 0.42 nanometer. Graphene is the basic structural element of the some carbon electrodes, including graphite, charcoal, or CNT, and the fluorines. And we can see that how the material will be, that the flower, we can say up of the even top surface of the flower, the material is kept. The petals are not even affected because of the how it is lightweight is there. The structure is given honeycomb structure. It is linking one another. Each corner it is linked other honeycomb structure. The graphene properties, it is a linear spectrum. It covers most of the band spectrum, and also the one atom thick. The atom is Armstrong level. It is thick is there, and this mechanically is having a high strength and highly stretchable, very flexible one. Unique optical properties, high mobility. So that only that the graphene materials are many of the researchers are attracted and used in the many kind of applications in the storage, also electronic devices, or many kind of applications. Yes, we can see that in 2015 to 2020, the graphene materials are mediumly quality. That is touch screen and e-paper and foldable OLED kind of applications are used. Years together, we have been transferred to many kind of applications directly for the large area surface areas grown. High quality graphene materials are achieved and used in the high frequency transistors, logical transistors, and thin film transistors, and future devices also been used for the kind of graphene materials are used for many kind of application in future. Because of its inherent properties, graphene materials are used in many kind of applications. After 2004 only, the many kind of extensive research discovery came back in two-dimensional materials, That is in 2D crystals, many kind of materials are used like that, boron nitride or molten silicide or chromium oxide, chromium selenide and graphene, etc. Vanadium oxide, vanadium selenide and niobium selenide, etc. Having the two-dimensional structures and also the peculiar property will be achieved in the two-dimensional material, so that only the band gap of the material can be easily tuned in the two-dimensional materials for different kind of applications. An optical range, we can see that in the ultraviolet region, that is boron nitride material insulator, it is used, and then molten selenide will covers only small amount of visible light, and then black phosphorus, it is covered only small amount of visible light only near infrared regions. But graphene, you can see that it covers to visible to radio waves. That is so that only the optical region major coverage it is used for many kind of applications for electronics or other energy storage devices. The structures are given, how they look like. And band gap of the materials also there. It is the boron nitride is 16 electron volt, and chalconized materials will have 1 to 2.5 electron volts. Black phosphorus will have an 0.3 to 2 electron volt. Graphene is a zero band gap material. Two-dimensional materials in building blocks, how they look like means it will be used for sheet-like formats, and over that the two-dimensional above the zero-dimensional material also can be stacked on the surface of the graphene sheets, and also the sheet-like formats with the 1.5D materials also can be placed on that graphene materials for different kind of applications. And the two-dimensional materials like black phosphorus, diacylcyclonide, boron nitride, and it will be used for different kind of stacking of one-dimensional material or three-dimensional material, and be stacked between the layers of the in between the layers of the two-dimensional materials, and be utilized for the many kind of devices. And then the peeling of materials, so that is layered material 3D to 2D, that is easily the two-dimensional, most of the common two-dimensional prototypes can achieved, that is iron based material or bismuth or iron chloride or the lead or cadmium or silver, niobium, samarium or molybdenum or bismuth telluride. These materials can be achieved. The structures have been given in the figure. The extraporation means cleaving the materials. Like we can etch the materials using different properties, using the different synthesis methods, and also can be in between the layers. The material will be stacked inside that, and also it is used for the application point of view. And then the distance between the one layer to the next layer is approximately 0.34 nanometer. That is in Armstrong level. There were different temperatures. The ranges will be different. That is for 110 degrees Celsius will be 0.34, and 0 degrees Celsius for 24 hours is 0.57, and 5 degrees Celsius for 1 hour is an expansion is coming out from the graphene materials. And also in the 2 theta values to hexad, we can 2 theta also will be shifting in the peaks also there. The defect free means the broad peak will be formed in the Raman also. You can see that the D and G bands will be formed, and then G band will be raised with the sequentially when the purity is increased. And then the zone, and then the material will be mobilized in solvent also in the different kind of application. That the particles or the sheets will not be settled down easily. For the different for that reason only it is used in many kind of that is liquids, that is mobilizing liquids for different kind of applications. Intercalation layer of layered materials, that is many for two-dimensional materials is used for only for the intercalation of many layered materials of different applications. We can see that for the graphene composite, conductive additive, are all graphene electrodes, or conductive current collector coating, flexible electrodes used in lithium and sodium and batteries. For supercapacitors, heteroatoms doped or graphene polymer composites or graphene inorganic composite, all graphene electrodes and wholly graphene are used in supercapacitors. Heteroatoms doped or mass diffusion layers or catalyst hydrides and wholly graphene will be electrocatalysis. Heteroatoms doped and graphene composites or the cathode interlayer or sulfur encapsulated will be used in the lithium sulfur batteries. For different devices, for the two-dimensional materials are used for a different kind of applications. Like a substrate, it is like an it is used as an template. It is used for different kind of applications. So in between that, we can do architecturally. We can do the whatever we think in the two-dimensional materials. And one more thing, and also there, then phosphorine is one of the good material, two-dimensional material. Like graphene, it is a monolayer one and a single element. Like the black phosphorus, we call that is other material, elemental materials are silicon, graphene, like that. It is a silicene, germanium, and cyanine. Others like that one. It is called. It is the name is called. However, that structure also is different in the graphene to black phosphorus. We can see the channel like material is formed in the two-dimensional one that is called as a puckered layer structure. It shows a strong in-play in anisotropy, and also it has a very tunable band gap, and also high carrier mobility is achieved in the black phosphorus, so that only it is used in many kind of electronic devices, nano-electronic devices, in MOSFET or FET or transistor or gate, this kind of applications. That phosphorine is used because of its peculiar property, like that puckered is like layered channel. The mobility will be very fast because of the structure of the material, two-dimensional structure of the material, and then the puckered structure. That is why that is the layered like a lower one and higher one like that. This will be there. And the distance between the one layer next is in approximately 5.3 Armstrong. That is very, very low. Then coming to the band gap of the two-dimensional materials, it is easily tunable one, so that only it is used in many kind of optical properties. That is already we have said that that is boron nitride material, two-dimensional materials. It is band gap is approximately 6 electron volt. And then molybdenum sulfate semiconductor materials have 1 to 3 electron volt, and black phosphorus material have a 0.3 to 2 electron volts, and graphene is an zero band gap material. So that only it is used in many kind of applications. Already I told that the graphene material covered the nearly visible light to radio waves region, so that it will be used in many kind of optoelectronic devices. And also many kind of energy storage devices also. Challenges with the two-dimensional materials, many kind of challenges will be happen in the two-dimensional materials. It is toxicity, and then contact resistance, Scotty barrier or Fermi level pinning, removal of polymer residue without using oxygen plasma, relatively low mobility in chalcogenide materials, and reducing defects and mismatch of the film and the substrate during CVD growth when preparation material, reusable substrate and waste handling, clean repeatable interface after wet transformer without using metal catalyst, and pinhole free dielectric formation, scalable synthesis, and single crystalline large grain size. Like that would have many challenges will be happen in the two-dimensional material. You should overcome these challenges, then only you can do the two-dimensional material used for the many kind of applications. Application side, they have and many all field the two-dimensional materials are be used. That is from biology, sensor, electromagnetic interface, shielding, supercapacitor, battery, or electro and photocatalyst, like that. Many kind of materials are used. That is metal-based metal sensors are used. Graphene and carbon nanowires, and there will be polymers, polymer, graphene, metal hydroxides for supercapacitors, battery, metal chalcogenides, carbon nanotubes, or sulfur, metal oxides, like that. Metal, and for photocatalysts, metal oxides, metal organic frameworks, graphitic carbon, and then graphene derivatives are used for many kind of applications. That is for electrocatalyst, like that. Coming to the materials, material for supercapacitor materials, that is carbon materials have high conductivity, high surface area, and then graphene is one of the good material for the that is supercapacitor application. Not only single material, the graphene alone will not be eligible for used. Applied for the supercapacitor. The composite should be used for the materials. Limitations are small pores. And apertures may exclude the electron ions from penetrating, and then significant diffusion resistance and leading to low power density. And impurities are in porous materials are detrimental. And many materials are being used in supercapacitors, coming to the ruthenium oxide, metal oxide, polymers, carbons like that when used. And then it is a metal oxide material. Ruthenium oxide is a good material for a supercapacitor, but because of the cost effect, high cost, it is not being used in many applications because of it is very cost is very high. And then coming to that metal oxide alone, it has been used for the because of it is thermal conductivity and stability of the material. It is because of this reason it is not used in many supercapacitor application. Polymer also like the conductivity is very high, but thermal is very high for that reason also. When it is carbon materials, relatively low, stability is also very low. When it combined to that of other materials, it will be used as an synergetic effect is for combined, and then we can achieve the high power density and energy density values. Carbon-based materials, the nanostructural materials for supercap application. Advantages: reasonably high conductivity, relatively high surface area, excellent corrosion resistance, high thermal stability, controlled pore size distribution, satisfactory compatibility in composite materials, cost effectiveness. Carbon materials are very low price, that's why only it is used in many applications. Limitation: poor energy storage capacity, inferior rate capacity. So here it shows some of the carbon materials used for the supercapacitors, aqueous electrolyte and non-aqueous electrolyte like that. Activated carbons, they have a large surface area, nearly 2,500 meter square per gram, relatively good electrical properties, moderate cost. Porous structure of activated carbon also possesses a broad bore size distribution, less than the 2 nanometer, meso pores 2 to 50 nanometer, macro pores of greater than 50 nanometer like that. Maximum capacity can be achieved when a pore size is obtained materials with matches with the ion size of the electrolyte ions. Maximum capacity can be achieved in the supercapacitor. And then carbon nanotubes, so one of the good material which exhibit superior electrical conductivity and then mechanical conductivity and thermal conductivity also achieved in for the carbon nanotube. And surface area also very high, that is greater than that of 500 meters per gram. And then angular tubular structures can preserve intrinsic CNT properties, electrochemical performance electrode material. And then only thing is there is a present difficulty is the purification and high cost of production. It is very difficult for CNT, so that only it is limited in supercapacitor application. Graphene-based materials attracted by the many scientists because of its inherent property, and also structure is also given in the linking RGO materials. Reduced graphene oxide materials have many linking bonds and on the surface of this layer, so that it will be attracted with the different materials. And linking will be electrostatically attracted, and then we have a less resistance, charge transfer resistance value. It will for parameters will be combining the parameters in the performance of the supercapacitor will be increased. Here are some of the examples that the metal structures of supercapacitor applications in nanotubes like that. It have nanofibers, the efficiency having 77.3% efficient charge retention, and then capacitance values of 1647 farad per gram, like tube-like structures is formed. And then it is in the carbon cloth. It is the carbon material will be coated on the surfaces of the carbon material. You'll use for applications of the supercapacitors. It have 1587 farad per gram, and then fast electron transport also successful being occurred in this kind of structure. And then the porous structure, that is nanoporous materials, that is 3D graphene and cobalt molybdenum oxide hybrid electrodes possesses the high performance in supercapacitor values. And then metal nitride material, nanostructures materials also achieve the high performance in the supercapacitors because of its high excellent electrical conductivity. So that the reason it is used in the supercapacitors. And then electrolyte performance validation using supercapacitor values are the three electrode cells and two electrode cell, or sandwich flexible electrochemical cell, or fiber electrochemical supercapacitor perform. Depends upon the application. Any kind of electrodes can be fabricated and then tested for the different kind of one. This kind of activities for tested for the supercapacitors. Some of the challenges to be forwarded in the electrochemical supercapacitors, like insufficient electrochemicals supercapacitor power window values of electrolytes and their effect of energy density, and then matching between the electrolyte and electrode materials affect the overall environment. Fundamental understanding of electrolyte processes the electrochemical supercapacitors. High charge capacity and minimum value of ESR using is not cost effective way. And morphology and dimensions of metal oxides, nitride materials are needed for morphology. Electrode materials have a sustainable influence on the speed of ion transfer and capacity of storage. High cost of electrolytes, electrode materials. Design engineering, including the current collectors, electrodes, electrolytes, membrane separators, counter electrodes, as well as assembling of devices, need a deeper investigation. Okay, there are some challenges. Here comes some materials which we have synthesized in our lab and used for supercapacitor application. Graphene based material nanocomposite are been fabricated in our lab and used for supercapacitor and tested for the supercapacitor applications. And molybdenum materials, molybdenum sulfide material, both are layered materials. That is, and molybdenum sulfide is also a layered material. Graphene also a layered material. Both are combined to form nanocomposite. In the same figure here shows the dimension morphological view of the material, and also that in the 5 nanometer magnification, so that the spacing value of the material lattice pattern of the material. And then it is Raman confirmed that the carbon material and also the molybdenum sulfide material XPS run the and then the bit we calculated that pore size and pore volume of the material 1 to 2 nanometer pore diameter, and then 2 to 7 meter for the composite material, and high surface area is achieved for the composite material. And electrode studies, we have studied the three electrode system for the different kind of electrodes for composite and pure graphene oxide material, and also studied that calorimetric charge discharge studies, and then charge capacitance, charge tension capacitance, and coulombic efficiency also we have studied, and achieved the high capacitance value around 290 farad per gram for 1 ampere per gram. Also, achieved the high energy density and power density for the composite value compared to that of the other materials. And then for the you have done also another work on the magnesium doped, then molybdenum material and the graphene nanocomposite material. In the structure, the morphological clearly shows that the Mn doped, the MO4 material has been acted on the surface of the graphene material. And then Raman also shows that the DG bands are formed because of the presence of the graphene material on the surface, and also intensity of the DG bands also G bands decreases when it comes to that RGO material. The D band increases because of the purity also increases. And then electrochemical studies is performed on the for the composite material, and this also we have studied the three electrode system, and we achieved that above 300 farad per gram for 1 ampere per gram current density, and also the stability of the materials is very high. 97% of materials achieved for the composite material, and for the pure material is very low. The stability of the material is very low. With that, we have concluded that the material can be used for the electrode is used for the supercapacitor applications, and we have also done the graphite carbon with nanocomposite, bismuth sulfide nanocomposite for supercapacitor application. And then here we have formed that of nanorods formed on the surface of the graphene sheets, and also we can EDAX mapping. We have seen that the bismuth, bismuth, carbon, and sulfurs are present in the sample, composite sample. And we have studied that three-electrode system, and the efficiency also very high, stability of the materials is very high, and the so capacitance is also very high for bismuth sulfate, that is 650 farad per gram in 1 ampere per gram, 1 ampere current density value. Efficiency also above 97% is also very high. And also in that we have fabricated an asymmetric supercapacitor device for the composite material. Actually, carbon will act as an cathode, and then positive material, the positive electrode we have designed with the bismuth sulfide and graphitic carbon nanocomposite value on the substrate, and two electrode system in a solid state electrolyte, PVA plus Na2SO4, and also we have studied the electrochemical studies and performed and then fabrication with a pouch type cell, and also we have glowed one LED value, LED cell, LED light, and 1 minute charging, 60 seconds charging. We have achieved 66 minutes discharging of light in an LED in a 1 centimeter 1 centimeter cross coated material and electrode material for the supercapacitor application. Last, and then I should acknowledge my mentor and guide, who is my role model of my career. That is Professor R. Jaivel, Dean AC Tech Campus. Sorry for the inconvenience.
Yes, 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 sir. I think due to some network issue, sir
Yes,
has
sir.
been
Yes,
left,
yes.
and I think he has joined.
Last minute interruption came. The phone call came, so that only is interrupted, sir.
Yes,
That
yes, sir.
only.
No, no issues, sir. Kindly share your presentation, sir. No, yes, sir.
Sir, which slide is last, sir?
Last slide, that is the thank you slide, sir. You have mentioned the
Okay, okay, sir. Thank you, sir. Thank you.
acknowledgement slide, sir. Yes, sir.
Okay, okay.
Thank you.
Thank you, sir. Thank you. Thank you, sir. If any questions or clarifications, let me know, sir.
It's time for asking questions. I invite the participants to ask questions. The participants may ask your questions now or kindly type your questions in the chat box.
Dear participants, if you have any queries, you can ask, or you can type your question in the chat box also. I think. Thank you. Session was good. Yes. Yes, sir. If there is no queries, let us
Yes,
thank
Dinesh
our
Kumar,
speaker. Yes, sir.
one question is, what should be the
Sir, one
considered as the
question.
best charge discharge time
Time
for
for
supercharge?
super capacitor. Yes, sir.
That is, we should consider about the storage sites, that is the active storage sites for the anions. That will be the major parameter for charge discharge time, and also the resistance, charge transfer resistance. We should look over that, and then uh, conductivity, and then ionic mobility of the material. You should look over these are the parameters for the high charge discharge time. These are the parameters. And then large surface area, that is a major one for the contributing in the supercapacitor application. Surface area of the material, these are the parameters. Dinesh,
Yes, sir.
that's all. That's one question is asked
I
from the
think
sound box. But then
my
what
Mayuresh
is
has asked that
annealing
question.
temperature of MOS2? That is 400. That is different kind of structures will be formed in the MOS2 material. Molybdenum sulfide material, that is molybdenum sulfide material, that is 400 annealing temperature is we have fabricated or synthesized the material in hydrothermal method only. That is 180 degrees Celsius in 24 hours. For different kind of synthesis methods are there for molybdenum sulfide material for different kind of applications. That is the one. Second question, sir. That is, what is annealing temperature of MOS is asked. Mareshwaran.
Yes, sir. Mareshwaran. I
Yes,
think
sir.
he has get the answer. I think so.
Yes,
Two
sir.
of them has raised the hand. One is Arun Kumar and another one is Gentronics.
Sir, one more person, Neithu Anidil.
Yeah.
Sir, can you provide some
Yes,
information on optical properties of graphene and graphene-based composite material?
sir.
uh, Optical properties, the optical properties I have told, I have shown in the slide also, that it covers the major region of the band spectrum of the band, so that it is used for many optical application, optical applications. And when you compare to the composite, when you combine with the composite materials, the band gap will be varying for, and also the band gap can be easily tuned for for purpose of application. What purpose we are going to implement the application for that reason. Now, generally, graphene is an zero band gap material, so that for that reason only many applications will be dropped. Zero band gap material. Then only the scientists will be involved for the doping the material. That is combining the material, the composite material for a different application. Then the band gap will be tunable. That is the reason why.
Sir, one more question, sir.
Mm.
In near future, how much more energy density do we expect?
That is, energy density will be depends upon the capacitance value, the specific capacitance value of the material. That is 349 watt hour uh, watt hour per kilogram have a major one. It is now that is highest value achieved in the energy density value of the material for supercapacitors. And then it will be differing for the application side. That if it is a small size, it will be the varying. The energy density will be varying. And if, energy, how much area we are fabricating, that is a major one for looking forward for that, the energy density. That is, in small lab scale value will be very small, but if it comes to a commercial, the energy density will be differing. So the value will be differing. The area of coating value of working electrode. That is the one for the which tells about the energy density of the material. We have achieved that is 349 watt-hour per kilogram value, energy density value for 1 centimeter 1 centimeter.
Thank you, sir. If any other questions, you may ask.
I think the participant Mayuresh has get the answer. I think so.
Yes, sir.
Also, Arun Kumar has raised the hand. Please ask your question, Arun. Also, Tirumalai Balavan also raised his hand. Kindly ask your question or kindly post your question in the chat box. Also.
Good morning, sir.
Good morning, sir.
Sir, can we dissolve the carbon nanotubes in ordinary organic solvents, sir?
We cannot dissolve the carbon nanotube in then dissolve solvents, sir. It is a highly mechanical strength compared to the. You are asking carbon nanotube only, sir. CNT.
Yes, sir. CNT only, sir.
CNT is the very hardest material, sir. Compared to diamond, it is a very hardest material. Till now, diamond is an very hardest material in the earth. Upon that, carbon is very high very high mechanical strength one, and also the it cannot be dissolved in any solvents also. In acidic condition, we may collapse the material. That is the one. We can, if structure will be collapsed in acidic conditions because of it is acidity.
Yes, sir. Yes, sir. Thank you, sir. Thank you, sir.
Thank you. Any other questions?
Kumar? Yes, Arun Kumar. Do you have any doubts or clarifications? You have raised your hand. Also, the Gentronics, the participant side. You have raised your hand. Do you have any question? You may ask, or you may unmute your phone and you may ask your question, or else you can post your question in the chat box also. Yes, if there is no question, I thank Dr. R. Tangappan, who is the Assistant Professor of Energy Science and Technology, Periyar University, for kindly accepting our request and deliver a wonderful talk in the field of supercapacitor application. Once again, from the Gonzaga College of Arts and Science and from my own behalf as a convener of National Webinar on Smart Materials and Application, I thank Dr. Tangappan for delivering his wonderful lecture, and it may be useful for all the participants. If the further doubts or clarification means, you can contact our resource person. Thank you, sir. Thank you for accepting.
Yes, sir. Thank you. Thank you very much, sir. Thank you for your giving the opportunity, and also thank you one and all, sir. Thank you. Thank you for your patience. Thank you, sir.
Yes, sir. Welcome, sir.
Shall we move, sir? Dinesh, shall we disconnect? Shall I disconnect?
Yes, sir.
Okay. Thank you. Thank
Yes,
you.
sir. Thank you, sir. Participants, kindly be patient. Within 3 to 5 minutes, we will start the second session. So kindly be patient.
Sir, Sudhakar sir. Yes, sir. Sir, it is audible, sir. Sir, Sudhakar sir. Is it is audible, sir?
Yes, sir. Yes, sir.
Hello? Sudhakar sir, shall we start, sir? Sir, Sudhakar sir, is it is audible, sir? அதான் அவங்க Dear participants, kindly please wait. Our resource person, our scientist Sudhakar sir, going to share his PowerPoint presentation. There is some issue, and once it gets cleared, we will start the session. Thank you.
Hello, sir.
Yes, sir.
This is Sudhakar. Yeah, it is audible?
Yes, sir. Yes, sir. It is audible, sir. Now it is audible, sir.
Yeah. Thank you, sir. Just 1 minute. I'm sharing my slides and then we'll continue.
Sir, wait, sir. We have to give the chief guest introduction next session. Start
Sorry,
with
sir.
the chief guest.
Yeah. Okay. Actually, I'm ready. So whenever you're saying, I will start. Okay, sir.
Okay, sir. Thank you. Thank you so much, sir.
Thank you.
Yes, sir.
Let us start the second session. I call upon Dr. M. Manivannan, Assistant Professor, Department of Physics, to felicitate Dr. S. Sudhagar, Senior Scientist, Electrochemical Power Sources Division, Karaikudi. Welcome you, sir.
A pleasant morning to each and everyone present here. It's my privilege to welcome Dr. S. Sudhagar, Senior Scientist, Electrochemical Powers Resource Division, CSIR Sikri, Karaikudi. He has completed his postdoc research at Chonbuk National University, Korea in the year of 2010. Later, he has joined as a scientist and he has promoted as senior scientist in CSIR National Physical Laboratory from 2011 onwards till date. So far, he has 12 years of research experience in his career. During his period, he has published more than 30 national, international research articles in highly reputed peer-reviewed journals. And he also presented his research findings in more than 25 national and international conferences. He also published 2 books and he also evaluated nearly 11 PhD theses. In addition with that, he has completed 3 major projects funded by MNRE, CSIR and NPL with a total funding amount of 5,030 lakhs. And currently, 2 projects are under ongoing process with a total fund of 9,400 lakhs. Sir has received so many awards like JRF, SRF, Traveling Fellowship Award by Tamil Nadu Science and Technology, and he has received a special award called Japanese Young Scientist Award in the year of 2008. Such a great personality we have today with us. I hope the day will end with a pack of knowledge. Sir, we are so happy to have you on this day, sir. Now the section is yours. Thank you, sir.
Yeah, thank you very much, Dr. Manivannan, for a very brief introduction. And before I starting, I wish to thank my heartfelt greetings and thanks to the organizers of this national workshop, and very particular to this Gonasa College of Arts and Science for being celebrating this National Science Day. Just 1 minute, I will share my slide. Is it audible? Myself, it's clear to you?
Yes, sir, it is audible, sir.
Yeah, thank you very much. And just I'm sharing my slide. Yeah, hope my slide is shared, right? And I will make it to full screen now.
Yes, sir, it is visible, sir.
Yeah, now I made it to full screen. So it is in full screen mode now. Is it in full screen, sir?
No, sir.
Not in full screen. Okay. Well. I think there is some issue. I'm getting in full screen, but it's not sharing. Yeah, anyway, I think we can proceed with this. Yeah. I think now we would like to see like lithium ion battery. It's a safe handling practices. Okay, if there is any issue or in between you could not able to hear it properly, please stop me at any time, so that I could be able to make it properly. Okay, and now in this conference itself, okay, I feel most of you could able to in this conference itself, like there are totally 5 sessions, out of which you can see that 3 are mostly on energy storage devices, right? So out of 5 we are getting like 3 in energy storage devices itself. That itself make it like how much important is this energy storage, and it is a very very hot topic today. In particularly energy storage devices, we are going to see about lithium ion battery and how to use it safely. That is our objective of a presentation today. So my objective is like 1 minute it is. Yeah, it's going. Totally the objective is like understanding of lithium ion battery and how to use it safely. Okay. Why means everyone, before going into that, let us see like there are a lot of research organizations in our country, majorly like CSIR, DRDO and ISRO. You see that CSR we are having 38 laboratories across the nation, and DRDO also they are having more than 46 laboratories, and ISRO 35, and Indian Council of Forest Research and Education, and ICER, Indian Diamond Institute, and the National Sugar Institute. And there are so many research organizations existing in our country, and it depends upon your field of interest. You can choose your research for further advancement. So there are a lot of scope and opportunities. These are very limited. Even other than this, we are having a lot of IITs and NITs to carry forward our research. Particularly, I am working CSIR, Council of Scientific and Industrial Research, and you can see that we are having 38 laboratories, starting from Materials Processing Research Institute, and then National Physical Laboratory, those who are interested in physics, and National Chemical Laboratory, which is located in Pune, and Indian Institute of Chemical Technology, Indian Institute of Petroleum, so many. Okay, so out of these 38 laboratories, we are working in majorly all fields of science and technology. Okay, yeah, and then you see these are some of the pride achievements are CSI milestones. So NPL CSR National Physical Laboratory has been make that first technology for Indian ineligible ink for election, and then Amul baby milk products and Swaraj tractor, and even Hansa aircraft. This is the lightest aircraft, indigenous flight, totally indigenous. Okay, not even a single component has been imported. Whatever be the thing, it is a seat or a tire or anything, whatever be the things, it is totally 100% indigenous aircraft, that called as Hansa, which has been made by our CSIR NAL, National Aerospace Laboratories, which is located in Bengaluru. This is a 2-seater flight, and then there are so many improvements in that, and right now they could able to make it to 30-seater flight. And even today, these indigenous aircrafts are used for our military as well as rescue purposes, army, totally army training, military training, and any rescue purposes. And these flights are used in our military. So these are the things we have. And these are very short, small examples, and there are n number of lakhs and lakhs of technologies has been transferred. Even if you go and get some medicines, okay, for example, arthritis, who are having the joint pain, you can go and ask for arthritis medicine. In that, you can see that CSR logo will be there. Okay, and even if you go for the mosquito sticks, okay, like agarbatti type of mosquito sticks, particularly Mosbic. Okay, the company name Mosbic. So you can see our CSAR symbol is there. So a lot of technologies has been transferred for the upliftment of our life today. And this before going to it, we can see that what are the research or what are the opportunities for students CSR is giving. So CSR is providing junior research fellowship for pursuing your when you are doing your PhD at the starting stage, 2 to 3 years, you could get junior research fellowship, and then you can convert into senior research fellowship during your PhD program. Then they are providing travel fellowship if you want to go for abroad to make your presentations or to attend any abroad conferences. So CSIR is giving travel fellowship. Not only CSIR, there are other organizations like DST, Department of Science and Technology, also providing you travel fellowship so that you can avail this travel fellowship. It includes everything like your airfare, stay, food, everything will be taken care by government, DST, and even CSR is also supporting this. And we are providing like internship or project guidance also. So as I in the previous slide I showed you like the 38 laboratories, right? In any of the laboratories you can walk in and you can easily approach and you can do your internships or projects also. Either if you want to do your master's project or your MPhil project or any projects, you can able to walk in any of the laboratories. You can approach properly well in advance so that they will give you permission so that you can do your research work along with us. Okay, suppose if you are interested in leather research, you can approach Central Leather Research Institute, okay, which is located in Adyar. In particular, if you do want to do in physics, then you can approach the National Physical Laboratory. Like that, I'm saying. Okay, so depending upon your field of interest, you can easily approach any of the laboratories and you can do your project also. And regularly, we are conducting skill development training programs. For example, maintain that how to maintain and care of lead acid batteries, and even AC mechanic training courses, and even sieving also we are giving a training for the skill development program. Throughout the year we are conducting regularly maximum of 1 week training courses, certified training courses for the upliftment of the some particular society and for the initiation of startups. Okay, so regularly we are conducting this skill development programs. You can easily check it out in our website. So what everything is defined in a year. Starting of the year itself, we could able to fix our what type of course is going on, which date and time. Like in the month of March, so this will be corrosion and corrosion resistance painting. Like that, it will be already decided, and every year it is a pre-decided and well-planned skill development programs. And other thing is like to conduct we are providing financial support to conduct conferences, symposia, workshops, and grant in aid projects. So these are the opportunities when students can avail, and even school students also can walk in to get their summer internship, like summer program for 10 days, even 1 month or like that. So now the gates are open to all. Earlier there was a lot of restrictions before 2016. Now the gates are open, and we are welcome our young minds to join hands and work together with us. So these are some of the opportunities. And other thing is like in CSR we are giving our own PhD program in biological sciences, chemical sciences, physical sciences, engineering sciences, and admission process twice in a year. So I already mentioned that you can able to do your MSc or MTech or MPhil projects with us. This is the main campus, our SICRI. It is around 300 acres of land, which was donated by Sri Vallal Alagappa Chettiar. Okay, so you see the visionary leader at the time exists, the great visionary leader Alagappa Chettiar. He has donated 300 acres of land, and even at the time it is nearly 1947. He has donated this 300 acres of land, as well he has given 15 lakhs cash to the government of India and has to start the laboratory over here in Karikudi. Okay, in the time of 1947, you think about the visionary leader. Okay, no one can able to do it at this time. So 15 lakhs cash and then 300 acres of land to start this electrochemical research institute at this remote place of Karaikudi. This is nearly 75 years we have completed our foundation day. So at the time itself, the great philanthropist, the great leader, has I think that electrochemistry lab is required in India, that particular to this remote location like in Karaikudi. Okay, so this is the main administration building, and then we are working in different divisions like corrosion and metals production, electrochemical power source division, electroplating and metal finishing. This electroplating and metal finishing, we have given our technology for ISRO also, Indian Space Research Organization. That you can see that any rockets in a rocket, the fuel tank should it should withstand that very high temperatures of the more than 3000 to 4000 degrees centigrade. So to withstand that high temperature, we have given some technology like through electroplating. which can maintain or which could able to support that temperature. So we have given that technology to ISRO, and still they are using our electroplating technology for their rocket fuel tanks and electrochemical process engineering and various other divisions. I particularly belong to this electrochemical power sources division, wherein we are working in the fabrication and testing of various types of batteries. Okay, so batteries, we all know lot of applications are there. This is the main building of our electrochemical power sources division, and in ECPS we are working in all types of batteries, like advanced lead acid battery, lithium ion battery, flow and metal air batteries, sodium ion battery, lithium sulfur battery, and as well we are working supercapacitors also. We all know lead acid battery. Even if you ask any people little like 20 years before or 30 years before, people at the age of like 40 or 60, you could able to, if you ask SICRI means, they will tell about battery technology. SICRI is known for its battery technology. For past 60 to 70 years, we are developing our battery technology, and we are giving it to, like, if you suppose go through Coimbatore, in and around Coimbatore, you can see lot of small startups and small scale battery industries, battery companies. So those people have been trained up from SICRI, or got some of the technologies like maintenance and how to reuse, recycle the batteries, and even I showed you know the skill development program. Through the skill development program, they could able to get the certified course, and then they are having their own battery shops or own battery company. I could able to see, even I could able to see that lot of small industries or companies are in and around in Coimbatore region. So SICRI is known for its battery technology from past nearly some 50 to 60 years onwards. So these are some of the applications of using batteries. We all know, starting from wristwatch or remote control, camera, camcorders, and even pacemakers. Even pacemakers is having small type of lithium-ion batteries, and this ear plug, and starting from small wristwatch to now we are talking about these electric vehicles. Okay, even it is a two-wheeler, three-wheeler, or four-wheeler. So the applications are very enormous. And particularly I am working in lithium ion batteries. Okay, not only this, even all of us, okay, all of us, we are having batteries in our hand, right, in form of like mobile phone. What are the mobile phones we are using right now, it's having lithium ion battery. Okay, so every one of us are having lithium ion battery in our packets or in our purses or wherever. Okay, so the application is very enormous and vast. So now in my talk right now, what I want to say is everyone is using like a mobile phone, thereby we are having lithium ion batteries. So how to use it safely, that is my main objective, okay, of today's presentation. So as till now, is it clear? My voice is audible and you could able to hear it properly? Shall we proceed further? Anyone could say?
Yes, sir. You shall proceed, sir.
Yeah. Is it fine? No, is it audible properly? And
Yes, sir.
yeah,
Yes, sir.
yeah.
It is audible, sir.
Thank you. We can proceed further. Yeah. The main purpose I mentioned, everyone is having mobile phones, right? Even small kids, from even the small kids means once the kids suppose now even the kid is not completing even the age of 1. Okay, to provide him or to feed the food also, now we have to show some mobile phone with some rhymes or something, so that the kid could be able to take the food. Like that, the kids are now are giving birth with the mobile phone itself. Okay, that much of mobile, the use of a mobile phone is very vast, but that should not be done. Okay, that should not be, that should be avoided. The kids are we are making the kids to take the food with the help of mobile phone. That is totally, it should be avoidable. Okay, that we should not do. Yeah. Yes, and these are the facilities we are having in CECRI, Central Electrical Research Institute, in ECPS division. So this is the first one you are seeing, like environmental chamber. Okay, environmental chamber in which you could be able to create our own environment. For example, the batteries are working in all stages of different places, right? For example, in Jammu Kashmir, people are using the mobile phone or this lithium-ion batteries. Even here in Tamil Nadu, it is the hottest climate, where we will have very hot climate in the month of April and May. So and even in the west or south, wherever there is a lot of climatic conditions variation is there in our country. Okay, it is not uniform. Everywhere it is like a different conditions are existing. Okay, but the battery are the same, right? There is no specific battery for Jammu Kashmir. There is no specific battery for Kanyakumari or something. So batteries are same, but the environmental working condition is different. Okay, so it should suit. Okay, and the battery number use பண்றது வந்து it should be useful to everywhere. It should be common to all, but so that the performance, it should be tested and validated very properly. Okay, for that purpose we are having this environmental chamber in which you could able to create our own we could create our own environment. For example, how much moisture should be there. For suppose if you think about in Chennai, okay, there the humidity will be very high. In summer it will be more than like 40% humidity will be there, whereas in other districts the humidity will be different. Okay, similarly the moisture content will be different, temperature will be different. So we could able to create our own environment. Okay, we could able to create our own environment with our humidity, how much moisture you need it, what is the temperature you need it. Even we could able to create our own artificial rain also. So at that stage we could create our own environment and we'll test our battery, how a battery is working. That is the IV characteristics, the current voltage characteristics at particular environment. So we could able to do using this through this environmental chamber. And the right one you are seeing is like the temperature bath. Okay, the batteries which are using in submarines or in salt water. Okay, those things we could able to put our own like sea water here and increase the temperature and study the performance of the batteries. And you see this is the right left one. That is that vibration tester. It will vibrate the battery in all the three directions, X, Y, Z, in a very high frequencies. Okay, it will vibrate in all the directions, X, Y, Z. So you could able to study the performance of the battery in this vibration tester. And the right one is the life cycle tester, how much life it will come, the battery should exist. For example, now you are getting your battery mobile phone in your any of the shops. The first thing we will ask that how much year it will come, how much year it will work it or something, right? But some people are there, they could able to change their mobile phones within like 3 months or 4 months. They are very fond of new mobile phones. Okay, so they could able to change it very frequently. But there are some people like me who want to use a same mobile phone for nearly for 10 years or 15 years or something. Okay, so for that the life cycle is very important. Okay, so how much time the battery should come, or how much time the battery will work or mobile phone will work, for that this life cycle tester will be useful. Nowadays the mobile phones could able to we could able to get mobile phones in the market of about life cycle some 4,000 to 5,000 life cycles. One life cycle is nothing but one charge, one discharge. Okay, that is life cycle we'll call. Okay, one life cycle is one charge and one discharge. Discharge is the useness we are using from morning to evening we are using, no, that we call as a discharge. And the charging we all know we are doing it right now. Okay, the charging we are doing. So using this life cycle tester we could able to check how much life cycle the battery can come. Okay, and this is the glove box for the fabrication of a coin cells. Whenever we are going for a big